Hello all. So in the last few sessions we were talking about regression model. We have seen types of regression. We've also seen how do we build a simple linear regression model, multiple linear regression model, polynomial regression model. After that we've also seen the performance metrics for regression, right? So today in this session I would like to talk about another most important topic which is called as generalization. So we'll see what is generalization, why is it actually needed, and two more important concepts in machine learning, which is overfitting and underfitting. So when I talk about generalizations, generalization is all about the ability of the machine learning model to work well with all type of data. When I talk about data, we have seen the entire data that we give as input to the machine learning model is actually divided into training data and test data. The training data is used for training the model, test data is used for testing the performance of the model after it is trained. Okay, sometimes the model may work well with training data but fails with test data. Test data is nothing but unseen data. Okay, so generalization is the ability of the model to perform well on new or unseen data after being trained on a given data set. After we perform training on the given data set, when I talk about test data or new unseen data, the model should have the ability to work well on new unseen data as well. So that is called as generalization. Okay, so when I talk about generalization, when I say a generalized model or well generalized model, it learns the patterns very well in the training data and such that it will also make accurate predictions on the test data. Why do we actually require generalization? To achieve good performance, okay, to get good results, or to make our machine learning model work well with real time data. When I talk about real time data, see, we get some data, we train the model with that data, but sometimes we may get to test the model on different new data that come in real world. Okay, so when the model have the capability of learning well with the training data, it will have the capability or ability to perform well on the test data as well. So giving that ability for the model is called as generalization. Okay, so there are so many different factors which actually is influenced by generalization. For example, complexity of the model, the quality of the data, the quantity of the data, the different types of regularization or different types of techniques that we use on pre-processing. Okay, there are different factors which will help us to design a generalized model. When I say generalized model, the model works well on both training data and test data. Okay, so for example, let me give you an example of spam email classifier. Okay, so when a person send an email, so depending upon the content that is available in the email, the email would be sent either to inbox or either to a spam folder, right? So this is a great example of generalization. Suppose you have training data set containing emails labeled as spam and not spam. Okay, so what is our goal here? Our goal here is to build a model that will accurately classify incoming emails, whether it is spam or to the inbox. When I get an email, my machine learning model should accurately classify depending on the content and put it to either spam or inbox. Okay, so what actually happens? Okay, let me divide this into two different phases. First, let us talk about training phase. Okay, so when I talk about training phase, what do? First, we do pre-processing. Okay, after that we do feature selection and extraction, and then the learning happens. So after learning we go for classification. This is what we have done when we were talking about developing the machine learning models, right? So during the training phase, the machine learning will actually learn from the set of labeled emails. Okay, so what do you mean by learning? Understanding the patterns that are available in the email. For example, let's say when I talk about an email which has the information saying you won the lottery with this amount, please get back to us, all that. Okay, so when you talk about amount, lottery, click on this link, so these words will generalize. These are the patterns that I am using in the email to generalize that is a spam email. Okay, so it will identify the patterns to make the predictions. Okay, so the model optimizes its parameters to minimize the training error and achieve high accuracy on the training data. Now when I talk about testing, okay, once I am done with training, I go for testing. Okay, so the true test of the model's effectiveness lies in its ability to generalize to new or unseen emails, not just on the training. If you have new or unseen emails, say these days scams are coming in different ways, right? Like we may get a link, or we may get a suspected link, or emails talking about money or all that. Okay, so even if you have unseen data, your model should be able to perform well and receive good accuracy and classify whether that new unseen email belongs to spam folder or inbox. Okay, so the entire data will actually divided into training data and test data, which we know. Apart from this, we'll also have validation data set, which we will use for validating the performance of the model. Okay, so when I talk about generalization, okay, as I told you, it will actually measure how well our model performs on predicting the new data or predicting on the test data. Okay, so when I talk about the best generalized model, it actually gives good performance with good accuracy on the unseen data. Okay, so before we understand generalization or how do I get generalized data, we will understand two different concepts which are called as underfitting and overfitting, which are actually best practices to train a generalized model. As you can see, there are three figures here. In the first figure, I am drawing a line which covers the training data well, but on the test data it will fail. Okay, this is called as underfitting. Okay, so there is another concept called generalized model, which I am generalizing, or the perfect optimal model, and this is called as overfitting model. So when you look into underfitting, the line is very simple. Okay, I am not putting much efforts in that. Okay, when you look into overfitting, I am trying to separate, classify these rounds and x's with with very difficult processing line. Okay, and this is optimal line where most of the x's are into one side, most of the circles are into one side. Sometimes two x's comes into this, that is, we may not get 100% accuracy, but that is an optimal model where we are getting a simple easy curve separating the two classes. Here in this case, many circles are in this, many cross are in this, so underfitting is not preferred. When you look into this, overfitting is okay, but the regression line that we have is very complicated. Okay, so we don't want overfitted model, we don't want underfitted model, but we want the optimal model, or we call it as generalized model. Okay, so there are different techniques and rules in AI for generalization. We use this process called dropout, regularization, cross validation, noise injections, ensemble methods, transfer learning, depending upon whether the model is overfitted or underfitted. So first we will understand what is overfitting and what is underfitting, and we will see what techniques to apply when the model is overfitted, what techniques to apply when the model is underfitted. So first, before we actually start with this, let me explain you what is overfitting and underfitting. Okay, so when I talk about overfitting, okay, so when you see this particular figure, this is called as overfitting. Okay, so this particular case is nothing but it works well. When I say a model works well on training data, so on training data, the model will understand well and perform well, gives you good accuracy. But when I give new unseen data, the model fails. Okay, so when a model works well on training data but fails on test data, that is called as overfitted model. Okay, overfitting occurs when a model that performs well on the training data but poorly performs on the unseen data, because this happens because it memorizes specifics rather than the generalizing patterns. This is what this. Okay, it just understand the specifics, not the entire generalization of the patterns. Okay, so this is where overfitting happens. Okay, so when you have too much high accuracy on training data but low accuracy and validation or test data, we say that the model is overfitted. Okay, so what is the reason for overfitting? Complex model with too many parameters. Okay, too many, for house price prediction, we take 20-30 input variables and then try to predict. When you have too many parameters to decide what the output is, we have this overfitting occurring. And second thing is, when you have small training data sets also, when your model is not trained well properly, obviously your test also fails. Okay, so when you have small training data sets also, you have your overfitting problem. Okay, now what are the solutions? How do I overcome overfitting? Okay, so as I told you, you can go for regularization. There are techniques like L1, L2 regularization. We'll talk about all this in the later sessions, but for now just understand that regularization, pruning, cross validation, like to evaluate the best model performance, we go for cross validation. We have early stopping, that is ending the training process before the validation actually starts, and then combining multiple models, which is called as ensembling. Okay, so cross validation, ensembling, pruning, regularization, all these are different techniques that we actually apply when we find a model which is overfitted. Okay, and then next, underfitting. Underfitting occurs when a model is too simplistic, stick, and it is not able to work on training data itself. Okay, the model is not understanding the training data itself properly, so obviously it does not work well on test data. So when a model fails working on both training and test data, we call that as well a underfitted model. Okay, low accuracy on both training and validation data sets if you get, then we say our model is underfitted. Okay, in previous case, low accuracy on test data but high accuracy on training. Training is well, test is failed. Okay, that is called overfitted model. When you talk about underfitting, training is also low, obviously test also becomes low. Okay, what are the causes? When the models are too simple, insufficient training time, if you don't have many features, okay, too many features, we get overfitting. Too less features, we get underfitting. Okay, so this is all about your underfitting. So what are the solutions? Okay, you have to increase the model complexity, that is you have to increase the number of features to find the underlying pattern such that underfitting can be avoided. And then you can also transform features into some patterns, that is feature engineering can be done. You can increase the training time, you can adjust your hyperparameters, that is hyperparameter tuning can be done. As I said, very small data sets leads to underfitting, hence you can also increase the quantity of the data set. If you have 50 samples, you can increase that to 150 samples by using different methods with which you can overcome underfitting. Okay, so if I want to give you a proof of it, I say fits too closely to the training data, it is overfitting. Fails to fit the training data as well is called as underfitting. Training accuracy is very high here, very low here. Test accuracy is low. Overfitting and underfitting, both of the problems. Okay, so in case of overfitting, training is well but test is failed. In case of underfitting, training is also failed, test is also failed. Okay, so example model, deep neural networks and small data sets, we have overfitting. Linear, very simple data, we have underfitting. Okay, so regularizations, early stoppings are different methods that we use for overfitting. Creating complex models, adding more features, hyperparameter tuning will avoid underfitting. Okay, so as you can see, too simple model to capture underlying patterns. So there are different patterns. So very simple linear regression line which is not able to capture the underlying patterns. So it leads to poor performance on both training and testing. This is called as underfitting. Optimal fitting is nothing but balanced accurately. One or two may be missed, but accurately balanced, neat line which is memorizing the training data set and give you a generalized curve which will actually classify different data. That is the blue square and the green circles. Okay, so overfitting too complex, the model is too complex. When you talk about training data, it works well with the training data but fails with the test data. Okay, this is called as poor generalization on the new unseen data. Okay, so this is all about what is generalization, what is underfitting, what is overfitting. We have to make sure that the model is not overfitted or underfitted but optimally generalized model. Thank you so much.